Hey everybody, this is Larry. This is the last day, right, of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. A quick minor update about my workouts as these are kind of like vlogs these days. I don't know, I didn't do much today. I just kind of ran like 7-8 miles, no, like 9 miles. So, I don't know, not much to do. Yeah. And it's tough, you know. I think that's the thing that I want to point out sometimes is that the hard part isn't doing the work, right? The work you can always, find interesting and find find ways to be amused, even grind through it. But it is the constant, the doing it every day and finding a reason to do it every day is the hard part, and that's the part that I'm still trying to figure out. And I have about, I want to say, where are we, week 6? So I have like 11 weeks of training left. So I don't know. The training is hard so that the running doesn't, the race is not hard, right? So we'll see how that goes. Anyway, let's take a look at today's problem, 1105, filling bookcase shelves. Okay, so the book supply has thickness, height. You want to place so that you have total width of shelf width. We're choosing some of the books that suggest the sum of the thickness is less than or equal to shelf width, then build another level so that the total height, then build another level of the shelf such that the bookcase so that the total height is increased by a maximum. Okay, that makes sense, I guess. Okay. Oh, you have to do them in order. So 1, 2, okay. N is equal to 1,000. I mean, I'm trying to think if there's another way to do this, but yeah, I mean, I think the first thing that comes to my mind is dynamic programming, right? Basically, the decision that you have at every turn is going to be, or at every book, is to start a new shelf or not, right? And what would that look like? Yeah, I mean, I think that'll be okay. That'll be n square. You probably could do. It's not as, I don't know. I think the n squared solution is pretty straightforward-ish. Let's see. Yeah, I mean, okay, let's do it that way then. Yeah, it's gonna be dynamic programming, or I'm gonna do it with memorization, top down. But the idea here, the hard part, of course, is just expressing it in a way, right? That's brute force. And here, then now, maybe you have something like get min index, right? And here, how do we want to define it? I know that I use index a lot as a variable name, but it could mean something else, right? Which is that given the suffix of books from starting from index, what is the remaining? What is the remaining total height of all the books or something like this, right? Of all the shelves, I guess, not the books themselves per se, right? So then here, if index is equal to n, then we're done, right? Oops. Then we're done. Then now we create an yeah. Otherwise, I guess there are 2 ways you can think about it. One is to do the tick no tick thing, but that part is a little bit tricky to get the cost of a shelf. Not impossible, but just a little bit trickier. And at that and also, yeah, I mean, we could talk about how to do that afterwards, but I don't want to do it that way yet because it is a little bit trickier. Not that much trickier, but a little bit trickier. And I think, technically speaking, it is strictly more space, but possibly a little bit faster in theory. I don't know. Right. So yeah. So then now here is okay. Let's create a new shelf or new level, shelf level, with starting with books of index, right? So then now we have, okay, so max height, or maybe it's gonna be shelf height, whatever, or like level height. Okay, is equal to books of index, because that's just this one, right? And then yeah, and then the result is just going to be you know, let's say best is equal to infinity, which is not what you want, of course. Then now we if you do one book, then it's just going to be get min of index plus 1 of level height, right? Oh, sorry, oops, index is 1 plus level height. That's it. What would 2 books look like, right? Then that's basically the basis for this idea, right? So that yeah, use 0, and then now for I don't know, offset in range all the way up to n. I guess technically I don't like to do, I'm a little bit lazy sometimes about doing the math because I'm always worried about off by 1. I think it's just like n minus index or something like this, right? Maybe I'm off by 1, I don't know. But the way I just like writing an if statement, even though it's slightly more inefficient. But basically, if index plus offset is greater than equal to n, then we just break rather. Otherwise, then now the new level height is going to be max of whatever the previous row was plus the current index, because then yeah, and then now we get min of offset plus 1 plus level heights, right? So then now this is the best, and we want to minimize this, and that should be it. I don't know, I'm feeling sorry, friends. I feel like I'm a little bit I think I messed up one thing, which is that I didn't count shelf with, I forgot about that. But level height is 0. Books of index is an int, right? Oh, it's a list of wait, what am I? Oh yeah, thickness and height. Okay, yeah. Whoops, man, I am like really missing. Sorry, friends. Today, clearly my energy level is not there. I just came back from the run and I'm off. This is obviously not right. I mean, it just puts everything in the same shelf, ideally. Though I think that is still wrong. Is that wrong? That should not be 1. Should be 2, right? Because you have a height 2 or even a height 3 book. So you, maybe that is not the, but there's no way that's 1. Huh? I mean, I know that this is 1 because I just forgot to consider shelf width, but I don't know why that this is giving me 1. I'm just like really off on something. But all right, let's take a look really. Sorry, friends. I feel like my explanation is just very weak these days. Well, today anyway. Okay, so 0, it goes to 6, offset of 6, level height is 1. That's not right. Oh, I'm an idiot. I just forgot this offset thing. Alright. There we go. Okay, 3 as expected because it just takes the entire shelf, right? Wow, man, I'm really sloppy. I don't know. It's just been going on. Having the marathon training, to be honest, is really draining my mental energy. I mean, I don't think I. I mean, I was like 3,000 not that long ago. Now I'm like, I don't know, slumping kind of poorly. But okay, so yeah, I mean, of course, the other constraint that we did not consider is shelf width. So then now maybe we have a total, but it's easy to add, right? So that's why I'm not really worried about it. It doesn't change the problem fundamentally, mostly because I think I thought about it as I was writing it, but then as I'm writing it, I just kind of forgot about it because I am not, I don't know, I'm just not good. But yeah, and then so then now this is the total width. If total width is greater than shelf width, then we have to break, right? Because then we can add this book. So yeah, so then that looks good. Yeah, this is basically just doing it one row at a time or one shelf at a time or whatever you want to call it, and then kind of brute forcing it, right? Of course, this branches many ways, and given that there are 1,000 books, that's going to be really, it's going to branch out a lot, and it's going to give you a timeout, right? So the way to cut that timeout is that you have this index thing, right? So then maybe you can write something like, whatchamacallit? Yeah, what am I thinking of? Yeah, just my usual. I don't know why I'm so bad today, right? Just someone like this, right? Just cache it. The reason why we could cache it is that for the same input, we always give the same output. So here, then we can just write, okay, if has cache of index, then return cache of index. Otherwise, at the very end, we save it down, and that's really it. I mean, just a few lines, and it should be much faster. Hopefully, I didn't make a silly mistake. Let's give it a submit. Apparently, I did it in C 5 years ago. Curious. I mean, I guess this is actually not that hard to write. So yeah, I mean, this is basically the same idea. Yeah, this is the same idea. Though I did it backwards for some reason. Don't know if that's necessary, but either way, yeah. What's the complexity here, right? This is going to be, well, how many inputs are there? The linear number of inputs. O of n number of inputs, and each input takes O of n's time. So this is going to be n squared time, and obviously, as you can see here, though, it's n squared. Oh, sorry, O of n space. We can actually further reduce this. I mean, not reduce this, sorry, but you can write it in a different way. I do want to. I do want to, just kind of give a glimpse of idea. Because sometimes, I mean, for this problem, it probably doesn't matter that much. The other way uses more space, but in theory can save some time, depending on how it's constructed, but due to the overlapping states. And it is something to kind of think about in general, right? If you want to get better, these are things you have to consider. And the way that you want to do it is, I mean, it'll be still O of n squared time, n squared space, or well, in that case, it'll be O of n squared time, but n squared space, but more overlapping space, more overlapping in inputs in general. And the way to do this is basically, there are a couple of ways you can think about this. One thing is noting that height sub I is 1,000, right? So yeah, so that kind of lets you play around with it. Because then now you can say maybe, okay, let's clear this up for a second. I mean, if you need this, take a screenshot or whatever. But the idea here is very similar to what we have now, right? And we'll put in the caching a little bit. Maybe I kind of want to do this another day just because I'm so tired, but I think this is actually worthwhile to do. Right, and the idea here is that, okay, let's say we have the start index, right, which is so the start index is going to be the first book in the row, right, and then maybe height for the height is the height of the row, right. So then now you can write 0, start index is 0, and then maybe the height will be books of 0, the index, right? Yeah, and actually we need to consider the width as well, so that we, is the height, oh no, height is 1. Right, so something like that. And you may be kind of curious, like if I did all these things, how is this still n square, right? We'll talk about it in a second. Don't worry about it, or worry about it, but we'll go over it. So the idea here then, of course, is just we have two options, right? We either start a new row with the current item, or just continue continue the row, I guess, if possible. I think actually technically we want maybe the index to be 1. Maybe that's a little bit cleaner, because technically I guess it's already encoded in here that we have that many books, right? So yeah. So then now, and this is just like a take no take thing, which we kind of talk about a lot in my channel. But yeah, starting a new row, what does that look like? Right? So we start a new row with the new index. So with the next index, the starting index will be the current index, and then the height is going to be books of index of 1, books of index of 0 is going to be the width, right? And then now we can add. Well, what is the cost here, right? Well, that means that we concluded the last row, which means that this is going to be height, right? Yeah. And also, let's I don't know if I believe this is the base case, so keep that in mind for a second. So this is the start new row, right? Is equal to this, and then continue the row is going to look like, okay, continue row is, what does that look like? So well, first of all, we have to check that we can contain the row, so that if width plus books of index of 0, so that's the thickness. If this is less than or equal to shelf width, then we can do it, right? Otherwise, continue row is equal to infinity, say, just to kind of, keep things together, right? Get min of starting the row. So yeah, so then the start index doesn't change. The height does change, because now it's books of index 1, and then the previous height, so the max of that, and the width is going to be just width plus the new width, right? So that's the new width, and that should be good. And then best is just equal to min of start new row or contain new row. I think in this case, if this is equal to n, then that means that we actually end the row, so that we actually return height in this particular case, right? Because that's the cost of the row. So here, when we continue the row, we actually do not need to add the cost yet, because we only do that when we conclude a row. So that's basically the idea. Yeah, and we could just run it real quick just to make sure that it works. It looks okay. So then now we can memorize, right? Well, okay, what happens? Well, index can be 0 to n. Start index could be 0 to n. Height can be 0 to 1,000, I think, right? Width can also be 0 to 1,000 or 0 to shelf width, whatever, whichever. So you may think to yourself, well, isn't this n to the 4th or 1,000 to the 4th? Anyway, maybe not n to the 4th, sorry. Isn't this, n squared times height times width? And, if you write it that way, it can be that way. But one thing to think about is that height and width is actually you could derive that from index and start index, right? Oops. Because you could think about height is just the max. I mean, and here we take the max, right? It's just the max between the start index and the start index and index, right? All the values in between. And in theory, I mean, you can pre-calculate this in n squared, just like have an n squared row, n squared like 4 loops, 2 for loops for start index, and then set height is equal to the max of that range. Of course, you can also do better with, you know, LCA or what's it called? RMQ type thing, range minimum query, right? Or in this case, it'll be max, so range max query. So you could do, my point there, I mean, I know that I said a lot of things, but my point there is just that you can do queries in n squared time to get the height, or to pre-process it so that you can get the height in O of 1. That's the key part, is that you're able to get this height in O of 1 if we did some pre-processing. The same thing with width, right? That's just prefix sum, and then you get sum of all the width from start index to index, right? And you don't even need prefix sum. I mean, you could do prefix sum so that you could do it in linear time processing. But like I said, even the same with height, you could pre-process it such that it is n squared, right? And you know, so in theory, these two, and in practice, so this variable and this variable, or this input and this input, these parameters are uniquely determined by the start index and index. So that's why you do not actually need to memorize these two. And we'll I mean, while I'm like going exploratory on this problem, you know, I mean, I think this is a fine problem to do this on. We'll go over what would that look like, right? We'll do that next. But that's basically the basis for what I'm trying to do and why this is n squared, right? So now it has cache, you could say same thing as before, right? Except for now it is n squared. Right, same idea as cache. Maybe you could cache it the other way, just because then maybe it's a little bit quick. I don't know. Doesn't really matter, right? And this is like should be at the end. My fault. Yeah. So this is the caching part, right? And this is the checking part. So what happens here, right? Did I save something incorrectly? Because this worked without the caching, so that it would be very awkward. Did I mess something up? Yeah, this worked without the caching, so why is caching? Did I type something weird? Huh. Dong dong dong. That is actually wild. Huh? It's too late in the day for me to ponder this. Why doesn't this work? Let's see. List object not cover. Is that why I'm having issues? Sorry friends, running into technical difficulties. Like this works without it. Did I mess something up? I mean, clearly something is wrong, but I'm at a loss as to why that is. Starting. I mean, the only reason maybe is that my height and that wouldn't make sense though. I think what I said is true. Oh, continue the row is wrong. Because this said index. Actually, I guess the inputs are just weak maybe. Sorry, that should be the start index. We did not change the start index, right? Okay, so that's still right, and then now the caching is right too. So actually that's kind of cool that, you know, as you can see, I got a little bit lucky on whatever that is. Oh, I see. Because I guess we don't really use the start index. Huh. I guess, yeah, I guess in the non-memorization version, you actually don't use the start index. It doesn't come up other. So maybe I kind of injected that without even realizing that I don't really need it in the brute force version. Of course, when you memorize, you can really, I mean, you can memorize on height and width, but I would say Yeah, I mean, but in even without the start, so yeah, that's actually pretty cool to kind of that's like a good learning bug. So what happens is that start index is actually not even, I didn't use it. I don't use it anywhere, right? Except for to kind of put it as a parameter, but it doesn't actually come up. And the reason why is that the start index is not necessary because it is uniquely determined by width as well, right? Just as I said that you can determine width from the start index, you can determine the start index by width, right? Because this is just the sum of sum of X books, right? And as a result, if you know what the current index is and if you know what the width is, then you could get the start index, let's say naively with a for loop, but you can also do a prefix sum thing, right? Or prefix lookup thing. So that's why start index is actually not needed, and you still get the right answer, though of course it would time out if you don't memorize. And actually though, because as a result of that, you can actually memorize by width as well. It would be the same thing. Because from width, you can get the start index, and from the start index, you can get the height, right? All the same thing. But the start index is just easier to remember, to figure out from here. Anyway, so yeah, so this looks good, right? So then we could give a submit. And yeah, of course it uses more memory because we literally are using more memory. I'm surprised it's not more, but in theory it's a little bit faster because then now you reuse some more inputs. And here, as I said, the height and the width, you don't need to memorize it. And as a result, I mean, not as a result, but just in general, it means that they're uniquely determined and you don't need to write it this way. But writing this way is just a little bit cleaner if you ask me. But for example, you can say width for width, you can, like this is an example of how I would maybe write this in a different way, is that, let's see, how would I want to think about it? Like I said, prefix sum, but I don't even want, like, you can do prefix sum, but I'm not even going to do that, right? But I'm just going to write, what's it called? Pre-cal width, pre-width, right? Is equal to, I don't know, just 0 times n plus 1, right? And here, then now you could just pre-calculate it in a very easy way, right? So for left in range, right? Width is equal to 0 for right in range from left to n. P width of left right is so width we added by books sub right, and we just equal to this is equal to width, right? And then now you could take this out if you really want to, and then write width is equal to p width of start index. Maybe this should be index minus 1 actually, but yeah. What? Oh, I forgot that this is always a list. Which one is the first one? Okay. Oh yeah. Yeah, this is no longer needed. That's why. But also it comes up here, right? So we have to correct these things. So yeah, as you can see, you could remove it very easily in this way, right? And yeah, it's surprising that I don't know if this is just like a Leetcode thing, because it is just a little bit too slow. More memory makes sense, right? But this is just as an illustration of what you can do, right? And also why you don't need to memorize it. But yeah, and then you can also think about this height is the same way, right? So your p height is equal to right? And then again, maybe your height is equal to 0 for right, and same idea, right? It is very easy to write, right? Because you can use n squared, because you know that this is going to be n squared anyway. So n squared is not going to be the cost, or at least it'll keep you in the same complexity. Of course, you know, there are constant costs and stuff like this, so you know your range might vary, but you know, like it might get timeout, but who knows, right? So then you could do that, and then now you could say height is equal to p height of start index minus 1, right? Oh yeah, I forgot this twice. Now we can remove it from the parameter, right? Oh, whoops. Yeah, makes sense. Minus stuff aside, right? But yeah, as you can see, these are all equivalent. I'm actually a little surprised it is that much slower, but I think it is that much slower because a lot of these loops are not really used, right? So it's doing more work actually. And one thing that we can do actually, and maybe we could tie them together, right? Is that well, for one, we can make an optimization here, and now I'm just having too much fun with this, right? So let's say we can move it here, right? Let's run it real quick, and this is how you do you know, test-driven development, right? You make one minor change, make sure that it still works before making further changes. I mean, it's a little bit slower, so you could call it regression, but you know, now we can try again. And the key thing to note is that, okay, well, if width is greater than shelf width, then now we can break. So that's the big piece that we probably didn't do. That is kind of part of the cell pruning thing. And as you can see, now we get rid of a lot of these things. And of course, even this max function is kind of a little bit pricey, you can say. So if you want to say it that way, then if book sub right of 1 is, this is a very Python thing. I don't, you know, don't worry about stuff like this unless, you know, you really need to. That should not be the first thing to optimize, right? But yeah, as you can, okay, that didn't even change anything actually. Sometimes that happens a lot. But yeah, but as you can see though, my point is just to kind of show you some, you know, some different ways of thinking about this and some different ways of writing this. And it ends up being a 30-minute video, but I hope that makes sense, right? I mean, I think this is a good example to do this in, just because, you know, this is a relatively, I mean, it's still not an easy problem, but it's an easier problem to kind of to explore and expand on these ideas. And then, yeah, and then when you are faced with a harder problem, then you can go back and kind of play around with it. So definitely play around with all these ideas. And of course, the other thing is that once you do it this way, you'll notice that start index doesn't change that much, and so you are able to write it bottoms up. You can actually use this and then reduce it back to linear space, it turns out, right? Because I think index only depends on index minus 1, right? So something like that. So there are a lot of things you can do. It's very funky, very cool, very. I mean, that I guess that would look like just 2 for loops. So I think that's just the you know. I guess if you think about it that way, it's just probably just this solution bottoms up without all the funky things. So I don't know, but yeah, but I just want, like I said, certain problems will require thinking about it in ways like this. In this particular problem, my first solution is probably the way that I would implement this, knowing all the constants and stuff like this. But yeah, again, this is going to be linear time. Oh, sorry, this is going to be n squared time, n squared space. So this doesn't really change that much, except for retraining space for, in theory, fewer cores. But yeah, in these particular inputs, it is much slower, but not a big deal. Yeah, just want to play around with it. Let me know what you think. Yeah, thanks for watching. Stay good, stay healthy, to good mental health. I will see y'all later and take care. Bye bye.